Hello friends, let's solve this amazing exercise we have here. We need to find the shaded area of the figure. Very good. Pay a lot of attention because we are going to start with the new series of challenges. This is challenge number 1. If you want to visit the challenges we already had done, I'll leave you a link right here so you can visit them. We have many challenges out there. Let's go for it. Let's get started. So, to find the shaded area of this figure, we're going to draw some lines. This indicates that this is a square because here we have two lines, right? Like a square, we know all its sides will be 10. Alright, let's start here saying every side is 10. Over here, these lines indicate that this side is divided into two equal parts. So this part is going to be 5 and this will also be 5. Let's
glue the shady area.
And we are also going to erase the lines. So as we said, this is going to be 5 from here to here and also to here. It's going to be 5, fantastic. So you'll agree that if the radius of this semicircle is infinite, the half which is, if the diameter is 5, the half which is the radius would come to be 2.5. This has to be 5 halves and this here also 5 halves. Alright, we'll call the small circle's radius r from one point. From the center to this tangential point has to be the radius of the small circle, which we will call small r. We draw a vertical line all the way down to this part of the line, from the base of the square. And here you will see 90 degrees. In addition to that, this line from here to here is going to be, how much is it going to be? R. Why? Because it's the same size as this line here, right? So this is going to be r as well. And since all this was 5 halves, this little piece here has to be 5 halves. Minus this piece over here, which is r, fantastic. Let's draw a line from the center of the semicircle to this part of the circle. And how much will this measure? It'll be 5 halves up to here. Nasab, here, 5 halves to here because it is the radius of the semicircle. And from here to here, well, yesterday, then this whole line, the hypotenuse of this right triangle red, 5 more, fantastic. Now over here, we can also draw this line up here. Pay close attention, we draw the line up here vertically. You'll also see 90 degrees here, and this part here will also be r. And if all these measures 10, then this bit here has to be, and this bit here measuring r is less. Fantastic. Over here, what we have is this part here that measures 10 because it is the radius of this quarter circle that I am pointing to here. Since there are 90 degrees here, this shape here has to be a quarter circle. So this is 10 and this little bit here is r. This hypotenuse of this right triangle we have here will be 10 plus this piece here, which is r. Phenomenal. Now what we need to find at this moment is the value of r. How are we going to do this? First, we're going to find this side of this right triangle here, which we'll call x. Using protractors, we're going to find the value of x, which is also this value here and this one. This distance here, okay? Alright, then we have that side x. Side a squared is going to be equal to the hypotenuse squared minus the other side squared. Which side do we want to find? So we have x squared equals the hypotenuse squared, which is this right here. 5 halves equal this squared minus the other side squared. The other side is 5 halves less. Whoa. 5 halves minus e and this squared. We are going to develop these squared binomials very well. Developing, we have the first term squared, so it would be 5 halves squared plus the double product of the first term without half by the second term, which is r, plus the second term squared. Again, we do the same, but with a minus here in the middle, so we're going to have the same as here, but with a minus in the middle, okay? So we have 5 halves squared
Nus sten halves.
Bayar and plus r squared.
Don't
Amazing.
give me...
We less in the middle. Then we have x squared is going to be equal to 5 squared, which is 25. And 2 squared is 4, 25 quarters. Plus we simplify the 2 with the 2. And it becomes 5.
Yes.
Plus r squared over here leaves us with less. The same as we have here, but with less in the middle. Not 25 rooms, less 5r and more r squared. And of course we have to multiply this sign by what's inside. So multiplying gives me minus, by plus gives me minus here. Less here, less minus Marana. Plus gives me minus, and we remove the parentheses. And this minus here, perfect. We can cancel out this r with this r, this 25 fourths with this 25 fourths. And we ended up with 10 raised plus 5 raised plus 5 raised, which is 10 raised. We applied the square root to both sides of the equation to get x. We simplify the index with the exponent and we get x. We don't state the properties of absolute values plus minus because we only need the positive part. And we have that x equals 10r. Fantastic. We now have the value of this part here, which is going to be the square root
From 10.
Fantastic. Very good.
Well, what are we going to do now? What we are going to do now is to find this red part here, this red line, which I'm going to call y.
So we have the side of this right triangle and we have the hypotenuse. It's the same as what we had here, one side and the other. So we are going to use the same formula to find y. Squaring that will be equal to the square of the hypotenuse, that is 10 plus r squared, minus the square of this side. 10 minus r squared. Note that around here we had the formula and the square is equal, we have a binomial squared, and then we have the same binomial but with a minus. So we're going to apply the first term squared. 10 squared is 100. The double product of the first times the second, 10 times 2 is 20, and times r 20, r plus the second term squared, r squared. Minus over here. We're going to have the same, but with minus in the middle. Not the first term squared. Minus 2 is the product of the first by the second. Plus the square of the second term. Really good. We have y squared equals 100 plus 20. R plus r squared. And minus times plus gives minus 100. This is not squared, but just 100 less. And sorry, less times less gives me more 20r. And less times more gives me minus r squared. We eliminate this with this here. And over here we have 100 negative and 100 positive. They also cancel out. And we have that y squared is going to be equal to 40r. Be careful. We apply the square root to both sides of the equation. Simplify index with exponent. And we get that it equals the square root of 40r. But for t we can write as 4 times 10 and all these times a. We take the square root of 4, which is 2. So we finally get that y equals 2 square roots of 10. 10 are phenomenal, fantastic. We have what we needed here. We have a 2 square root of 10 are awesome. We're going to erase this from you so we can continue, alright? Alright, I've erased everything and we're left with this perfect. Now what we're going to do is find r. How are we going to do it? We'll add this red line we have here with this red line that we have here. This line that is dashed with the solid line. And how much should this give me? It should give me 10 because it is the side of the square. So we can say that this here too, square root of 10r plus this part here, which is square root of 10r, it should give me, how much should it give me? 10, perfect. And here we can solve for 2 square root of 10r. Square root of 10r is 3 times the square root of 10r, and this is going to equal 10. Moving to divide by 3, and here we are. The square root of 10r is equal to 10 over 3. Perfect. We square both sides of the equation to get rid of the root. We simplify the index with the exponent and it leaves us with 10r, and over here we have 10 squared, which is 100, and 3 squared, which is 9. We divide by 10 and we're left with r equals 100 over 9, and this 10 moves here. We take out the 10th one and the 10th 10, and we find, ladies and gentlemen, that r will be 10. 10 9's, awesome. We already have the value of the radius we were waiting for so much to be able to keep changing, replacing data. Pay close attention. We will start replacing data and leave this here with numbers instead of variables. X and normal, y simple non-step. So here we have 10 minus r, but we are not going to put r but 10 9's. So pay a lot of attention. 10 minus r equals, how much is 10 minus r? Well, let's see. We have 10 less and r equals 10 9's. 900. 9 times 10 is 90, and 90 minus 10 is 80. So we're left with 89. Ladies and misses, this side over here is going to be 89's. What are we doing this, folks? Notice what I'm going to do.
Snakes.
What we are going to do, ladies and gentlemen, is to find the area of this triangle, which I'm going to call area 1. The area of this triangle, which I will call area 2. The area of this triangle here, that is going to be area 3. Let's erase this from here. Area 3! Very well. And we are also going to find the area of this rectangle here, which will be area 4. And if we square all these areas for us, we end up with the area of the triangle we need. So for that, we need each side. Notice this side here. I already erased it, but it was y equals 2 times the square root of 10r. Perfect. We need to replace the value to know how much this is. Yes, so let's look at 2 times the square root of 10. R will be equals to square root 10 times r, but r is worth 10 ninths. 10 ninths. Ninths. And then how much do we have? We have 2 times the square root of 100. 10 times 10 is 100. 100 ninths. So we have that 2 times the square root of 100 is 10. The square root of 9 is 3. Here it's 10, it's not 10. And the square root of 9 is 3. We get 20 thirds. 20 thirds. It's going to be the measure of y. That is, this measure here is going to be 20 thirds. 20 thirds, perfect. And we're going to look at this part here, so we could take away, right, 10 minus 20 thirds should give us this here, but we're also going to apply this here now.
I'm going to send
Square
you.
root of 10r, but r is worth 10 ninths. So 10 times 10 ninths. What remains for us is the square root of 109, and well, the square root of 10 of 100 is 10, and the square root of 9 is 3. We get 10 thirds. 10 thirds. Perfect, perfect, perfect. We have this part here that is 10 thirds, and since this is 10 thirds, this will also be 10 thirds. And we just need this base here to find the shaded area. What do we have to do? We need to add this here with this here. I have 5 halves more. 5 halves minus 0. 5 halves minus 0. Those over here, this is a homogeneous sum. We get 2 in the denominator, and 5 plus 5 is 10. Less r, and r, how much it measures? It measures 10 ninths. 10 ninths, ladies and gentlemen, these 10 ninths, right? So here we can also change this r for 10 ninths, because that's what it will be read. So who do we have left? 9 times 2 is 18. 10 times 9 is 90. And 10 times 12 is 20, minus 20 leaves us 70 over 18. Perfect. 70 over 18 is the base of the triangle of area 370 over 18. Ready? And with this, ladies and gentlemen, we can find the shaded area. Let's erase for the last time, and then we will find the shaded area. Perfect. Then we have, gentlemen and ladies, that the shaded area equals the area of the square, less than ugly square, right? The square's area minus area 1, area 2, area 3, and area 4 minus area 1, area 2, area 3, and area 4. Perfect. We then have that the shaded area is equal to the area of the square side by side, 10 times 10, which gives 100, minus area 1 is the area of this triangle base, times height. The base would be 89, 89 times the height would be 20/3. And all this about the triangle's area, we won't put it here. Triangle's area equals base times height divided by 2. Very good. Base times height over 2 minus area 2, which is also the triangle's area. The base is 5 and the height is 10 over 2. 5 times 10 divided by 2 minus area 3. Area 3 is this tiny triangle base, 78, 18 degrees. Will it be? No, here this is missing. This is a 1 already done. Base times height. The height would be 10/3. 10/3 here divided by 2. Minus area 4. Area 4 would be the area of this rectangle right here, which is base times height, which can be any base, any height. So we have 10/9 by 10. The 10/9 times 10. You go that way. Perfect. We have that the shaded area is equal to 100. Over here we can simplify. Of course we can. Half of 1 and half of 20 is 10. 10 times 80 is 800. 800 over 27 minus 800 over 27 minus around here. We simplify half 1 and half 5. 5 times 5 gives 27. 5 here. We can simplify. Of course half 1 and half 5. Half of 18 is 9 and half of 70 is 35. And let's multiply 5 by 5 is 25. Carry the 2. 5 times 3 is 15 and the 2 I carried makes 17. 9 times 3 is 27. Very good. Minus 10 times 10, which gives 100. Ninth, we have that the shaded area will be equal to 100 minus 25, which is 75. And over here we have 27 and 27. We can leave this in base 27 then. We multiply and divide by 3. And nothing happens because this equals 1. 3 times 100 is 300. Let's write down 300
1,
here.
2, 3, 4,
and
5,
3
6,
times
7,
1
8,
is
9,
27. Perfect. So let's erase this from here. And this is an addition or subtraction of numbers of homogeneous fractions we end up with in the denominator. Then the common denominator, which is 27. And at the top we add 800 and 300, which gives me 1,100. 1,100 and 175 is 1,275 phenomenon. We find that the amazed area, ladies and gentlemen, is 27 by 75, which is 2,025. And 2,025 minus 100,000. 1.275. That gives me 750, and all this over 27. Phenomenal, fantastic. We have already found the solution. Let's put square units here because it's about area. We have already found the solution to our exercise, but we will also leave an approximation. The approximation is 27.7 square units. Let me know in the comments if you like the video, and do not forget to subscribe and hit like so you do not miss the next challenge. See you another day. Bye bye.